This is our dissectable machine demonstration. So on the left, we've got a 3-phase wound rotor motor, and the rotor windings are dead shorted together, so it acts as a squirrel cage motor. On the right is a DC machine. You can tell because it has the commutator segments and the brushes right there. They're direct coupled together. We use this piece of equipment to show 3-phase generation and DC generation. So it just depends. Do we make that the prime mover? So we put 3-phase AC in to make DC, or do we spin the DC motor to create 3-phase AC on this side? Windings are brought out and we've got a voltmeter to see our output voltage. So right now, the DC machine is set up as a self-excited generator. And so it's going to make its own DC. It is based on residual magnetism. And so I'm going to use my VFD to spin my 3-phase AC motor right here. So I made this power supply to work in a classroom, so I could wheel this down to the class to run a 3-phase motor. So here we've got 15 amp, 120 volt standard circuit. Inside this box is a transformer that steps it up to 208 volts, and then that feeds our variable frequency drive, as well as we've got a rectifier to create variable DC, as well as fixed DC if you're going to use a separately excited DC generator. So if we just press go, start the motor, you can see it's starting to speed up. This is 6 hertz. I'm going to increase the speed. So here we're at 35-ish hertz. And you can see we're generating almost 18 volts. The negative is just polarity. We don't care about that. So now I'm going to increase the speed. So I'm almost 230 volts. So that shows that your generated voltage is proportional to the RPM. Now I've changed our configuration. So instead of hooking up my shunt field to the armature, I have it to my variable DC supply. So in this case, it's a separately excited generator. So we're gonna start our 3-phase motor. We're gonna accelerate to 35 hertz. So if you'll recall, this was producing almost 18 volts before, but my variable, so my magnetic field is off, or as low as it can go. So residual magnetism is producing about 4.5 volts. Now, as I start to turn up my DC, you can see the output voltage go up. Now note, the prime mover is moving at a constant speed. I haven't changed that. I'm just creating a stronger magnetic field on the field poles on my DC machine. The last iteration of this demo is I'm using my DC machine as my prime mover, and I'm going to make 3-phase AC out of my wound rotor motor. To do this, I'm going to be pulling power off the 3-phase stator, and that means I need to put DC on the rotor. So all I'm going to do is use a battery, and I'm going to power up that rotor, and you're going to be able to see that we get AC voltage out of it. So these leads go to my stator windings. So first things first, power supply's on. It's important to wire up the DC machine correctly. So you want to put fixed DC on your field poles, and then we're going to put variable on our armature so we have speed control. So as we now turn it up, DC machine will accelerate. If we have an output on this meter, it's because of residual magnetism. Okay. Now, challenging to do with 2 hands. There we go. So we got 30 volts. So my 9-volt battery is providing enough magnetic field to produce 30 volts, 3-phase AC. Take away the DC, you got nothing.